All right, this is part 2 of 10.3 extension, which is choosing appropriate measures. Okay, why do we use the median for measures of center when the data are skewed? Okay, why do we use the median when the data are skewed? And I think that just looking at this data set, hopefully you know, if I said describe the shape of this distribution, I hope you would know that this is skewed to the left, right? Because this is kind of like the slide. You climb up here, and then you slowly slide down to the left. So I kind of drew a picture in the last video, but these data down here, there are not a lot of them. Where's most of the data centered? It's over here, right? Here's where most of the data are, over to the right. And if most of the data are to the right, this is skewed left. That means that there's these values way off to the left. And what are those values way off to the left doing? It's kind of like the opposite of Bill Gates. Instead of a number that's way huge, these are numbers that are smaller, and they're pulling the mean to the left. They're like outliers that are pulling the mean to the left. Because remember, the mean is really affected by outliers. So the blank is easily affected by outliers and skewed data. The mean is easily affected by outliers and skewed data. So the blank, on the other hand, is not so easily affected by these factors. I shouldn't have used the word factors by these data values. I'll change that on your version of the notes. Which one isn't? Which measure of center isn't? Measures of center, mean, median, and mode. Which one is not as affected by outliers? The median. And if you don't remember that, you can go back to last chapter. In chapter 9, we talked about, I believe it's 9.2, where you're talking about the mean and how the mean is really affected by those outliers. But the median is not. And so that's why if you have skewed data is kind of like having outliers. Those data that are really far from where most of the data are. So we use the median. And then, of course, it follows, if we use the median as the measure of center on skewed data, which one of our measures of variation uses the median? Does mean absolute deviation? No. Mean absolute deviation uses the mean. Does the range? No, the range actually is affected by outliers. What about the interquartile range? The interquartile range, when you find those quartiles, the first thing you do is you split your data in half. And so you're finding that median. So the IQR is the best to use when you have skewed data. Okay, let's take a look at this example and see if it can help you understand this concept. I think you got this. Whoa. This thing does not scroll very well. Okay, how can we use a dot plot? Pause for a second, wait, dot plot. This is a data display. We studied stem and leaf plots, dot plots. We've studied histograms. Okay. How can we use a dot plot to determine the appropriate measures of center and variation? Okay, the dot plot shows the average number of hours students in a class sleep each night. How many of you are like 2, 1? Try to get more sleep. You'll be better off. You'll feel much better. I know it sounds bad. You want to stay up all night, but trust me, try it and see how you feel the next day. Okay, what are the most appropriate measures to describe the center, measures of center, and the variation, measure of variation? Well, first, what shape is this distribution? You climb the ladder till you slide down to the left. Right? This is skewed left. This is skewed left. So what I'm going to write here is that the data, the data are what? Skewed left. Data are skewed left. So what should we use? For the measure of center, for the measure of center, and I'm writing all this out, and you're probably like, oh my gosh, I'm so bored. When you write, you're spending time thinking about it. It'll make you understand it better. And I know just watching me write, you're like, I'm so bored. I know, but slow down. Give your mind time to actually have this information sink in. So for the measure of center, we use the, well, which one? These are like outliers pulling the data to the left. And so we don't use mean, we use the median. Right? N. And I have a little room here. I'm going to fit it in. And for, that's an F, for the measure of variation. This thing does not like doing eyes. Variation, we use the IQR. Whoa. Okay. All right. So describe the center and the variation of the data set. And so right now, what we're going to do is we're actually going to find these. It's not that hard. We can construct the data set with a dot plot. We can't do with a histogram, but we can with this. There's 1, 6. There's 1, 6.5. Whoa. There's 1, 7. There's 2 7.5s. How many 8s are there? 2 8s. How many 8.5s? 3. 8.5, comma, 8.5, comma, 8.5. I probably should have typed this in. And then there's, looks like 5 9s. That's right. 9, 9, 9, number 9, number 9. And then 3 9.5s, 9.5, 9.5. If you have to suffer by writing these, I will too. Mr. Plunkett, you're just, what a trooper. And 10. Now, my writing looks terrible. I think it looks terrible. And yet, good job if you actually wrote this with me. Okay, so we said the best measure of center is the median. And so we have to find the median. And I don't know if you remember how to find the median, but you have to find the center of this data set, right? And so I'm going to put like a dot. That's the way I'm going to do it. I'm going to put a little dot underneath. And then I'm just going to go in one number every time, right? Boom, boom, beam, beam, bump. 3, 4 numbers in, 5 numbers in, boom. 6 numbers in, boom. 7 numbers in, boom. 8 numbers in, boom. 9 numbers in, boom. So it looks like the center of our data is right there at 8.5. It looks like that's what it is. Just to make sure I have 3, 6, 9, yep. 3, 6, 9, yep. So the measure of center, median, the median is 8.5. Cool. And now we need to find the IQR, right? The interquartile range. And if you remember this, the interquartile range is based on the median. So we've already found the median. Now we just have to find the median of each half of the data, which are quartiles. And so I'm going to do the exact same thing that I just did. Maybe I could do it in a different color so I know that I'm not getting confused by these blue ones. Okay, boom, boom. Remember this cut out the number 8.5. So that median's cut out. Now I'm 2 in, now 3 in, and now 4. So it looks like I have quartile 1 is 7.5. And then over here, 9, and then that's 1 in. Now I'm 2 in from the outside, so 3 in from the outside, 4 in from the outside, and it looks like my quartile 3 is 9. And so to find the IQR, right? The IQR is quartile 3 minus quartile 1. Notice I'm cutting out these bottom data and these top data. I'm only focusing on the range between these quartiles. So all I'm doing is finding the range. And my highlight is going slow. I'm only finding how far it is from here to here. And this way I'm cutting out these tinier numbers, right? I'm cutting those out. I'm focusing only on those numbers that are in the middle of that data set. So is quartile 3 minus quartile 1? which is what? So 9 minus 7.5, which is equal to 1.5. So the IQR is 1.5. That ends part 2 of 10.3 extension, choosing appropriate measures. Catch me in part 3.